Are you able to hear my voice? Okay, thank you all. Okay, let's start the session. So yesterday we were discussing about arrays and that is how to pass a call by reference value to your methods, right? So there we did a small mistake actually. I'll just show you that. So just hold on. Okay. So hope you are all able to see the screen. So yesterday we were discussing about this. So actually, if you observe here, I'll just do one thing. So when you are doing reverse, right, I should pass each individual value, right? So I need to do something called a swap there. So that is a thing which we have missed. We can't directly pass a reverse of an array to the function because that will not be affected in your original array. So if you observe here, so as I have explained you about, that is how to, that is call by value and call by reference, right? So whenever you change something in your local, what do you say? Whenever you are changing some values in your local reference, that is in your definition part, it is also reflected in your main method. That is nothing but in the calling area. So here what am I doing is I'm passing your array method as a reference to your I'm typecasting this actually in star or something array. This is nothing but you're typecasting your array definition so that you are calling your method of array by a reference, not by a normal variable. So if you observe in line number 12, I'm calling the method name array1 and I'm passing two inputs. One is array and the other one is number of elements. Now the complete logic I'm implementing in the definition part of your array. Okay, I'm sorting all the elements and finally you are in input, that is nothing but you are just passing the ARR. Here ARR is nothing but you are passing the first memory location of your array which you have different. That is, we are not passing the value, we are passing the base address. With the help of the base address, your values are printed here. Okay, you can pass your base address. From the base address, whenever you print ARR of I, it start printing your number of elements of your array. So if I give 5, so you can see your elements of your array are sorted. Okay, so you actually, if I don't do this, like if I don't pass the reference, what exactly happens also you see now. I get the sorted array. So nothing. Why? Because still you are getting. This is only a warning you get. That is only a typecasting here. So why I am stressing on this point is already I have mentioned whenever I am talking about character array, I have told you that array itself act as a pointer variables, right? Array itself acts as a pointer variable. That is nothing but it has its own reference array. So by default, arrays are itself as a pointers. So only that warning you are getting here because as we are not typecasting your array as a reference, because written ARR will not return the value, it will return the first memory location of your array reference. So in order to typecast it, you are making your array as a int star pointer. So how do you do in your malloc? If I don't do that, nothing happens. So as arrays are the reference, that's the reason you are able to pass your entire list to the sorted array function and you are able to print that. So this is the method how even you don't write this, nothing happens, but you get a warning as you are not doing the typecast function. So what is this return ARR? Return ARR is not the value, it is the first base address of your memory reference. Okay, from there you are fetching your input values and you are printing the line number 15 of your array element. That is, your actual parameters will be modified in your base address. Okay, so if you do this, you don't get that warning also. I get 4, 5 and 6. Okay, anyone has any doubt with this? And anyone has any doubt with this? Class 9. Hello, anyone has any doubt with this? Let me know. Okay, so we will talk about fastly. So this is the way how you pass your arrays to a function, how your pointers can be referred to your function. Like I have shown you swap method, right? This is call by reference. Here you are making the values, you are passing the values, but here in your method name you are passing the address of that location. Okay, this is nothing but you call it as call by reference. The reference means address, value means value we are passing, that's all. Okay, you know why, what is the problem when I do this? Okay, if I don't pass the address, even you are doing the swap, you are implementing the swap technique in your function definition, the actual values will not be affected, only your local values will be affected. Okay, so we'll talk about the next concept, structures. uh, Ma'am, your voice is breaking. Okay. So the next concept we'll talk about structures. I'll just take one minute. Fine. So, so structures. Okay, so whenever you are talking about structures, the first foremost thing is actually structures are nothing but derived data types, and few say that they are user defined data types. It depends on the it is different from different users, but it is a user defined data type. To be very frank, structures are user defined data. Why we are calling it as derived data types is there is a lot of difference between a normal data type and structures. Because a normal data type, suppose if I say a variable int a is capable of holding only one type of integer value, but one structure is group of different data types. That is, is having collection of heterogeneous elements. That is, a single variable can hold a collection of different types of data. A single variable can hold a collection of different data. That is the reason structure is called as a collection of heterogeneous elements. Okay, here if you observe, a is a variable, but it can hold only one value of type integer. But when you define a structure, structure is also defined under one single variable, but it can hold group of elements, okay, of different data type. That is nothing but you call it as heterogeneous elements. So that's the reason structure can be defined according to user choice. Few of them can use your structures to define his details of a student. Some may use your structures for employee structure. It depends on as the definition, as the instructions which or as the values which you are going to enclose between these are different for different users. Okay, that is not common for every user. That's the reason structure can be talked as or called as user defined data type, and it is called as derived data type because you are deriving structures from the basic or primitive data types itself. Okay, now we'll talk about uh, structures. So structures are nothing but the first one. It is a derived data type. It is collection of heterogeneous elements which are referred under a single variable name. So you people should know how to in structures a basic structure. I mean, how you define a basic structure, how to pass an array to a structure. We should know this. How to pass a function to structure. okay, and how to pass a pointer. So if you know a simple program for all these concepts, that is more than enough. And in structure, the other one is they will be asking about um, type def. You'll be having enum. These are two expected things, and sometimes they'll ask about slack bytes and bit fields. So these are the concepts which are related for your JNDU. Okay, so one simple program you can implement in all the concepts of your structure. Okay, and you need to know what is type def. Okay, and what is meant by enum, and what are slack bytes, and what are bit fields. If you understand all this, that's fine. And then the next one is union. In union, you may have one basic thing is they will ask you to write the differences between structures and unions. Okay, that is one expected thing you will get. Okay, okay, one second. So let me take one simple example and explain you all the concept. Just hold on. Okay, so you will be asked a very simple question like read some student information, and we can print his details. So if you are asked with arrays of structures, okay, um, then you will be having another one like finding, I mean, reading the student marks. We have to read student marks, and you also need to find the total, average, and you need to calculate the grade of a student. This is also the other expected thing in your structures and arrays. Okay, one is reading the student and printing his detail. So extension of this, like you will reading the n number of students data, like marks Japan, n number of students data with marks, finding total, average, and grade of student. So this is most expected question, to be very frank. This is most expected question till now whatever we have seen. Okay, so now um, we'll talk about the first example. So always your structures are having a basic syntax. Okay, you may be asked you to write about syntax of your structure. Structures are defined with the keyword struct. Okay, Then you will be having followed by name of the structure. Under this you have members of structure. Okay, then you have structure variable. Okay, this is your basic syntax of your structure. Structures are defined with a keyword struct followed by name of the structure. Under this structure, you'll be having members of structure and you'll have a structure variable. Now you see, structure is collection of members are nothing but of type heterogeneous elements which are stored under a single variable name. So whenever you want to access or whenever you want to give the input to your members of your structure, we use a special symbol that is nothing but you call it as a dot operator. Okay, a dot operator, what is a dot operator does is it acts as an interface between members of structure and structure variable. Okay, so dot operator act as an interface between the members of structure and structure variable. So with the help of this dot operator, you are going to pass your inputs to the definition of your structure, or you will read the values for the definition of the structure. Now a simple program to read a student structure and print his detail. Okay, if you know one simple program, whatever the expected question, you can write it by your own. So now whenever you want to read a student, first thing, so student, under student class you will be having different parameters. So I'm taking three parameters first. Okay, I'm talking only about one single student. I'm not talking about set of student. I'm only talking about one simple student. I will read his name, I will read his roll number, and I'll read his marks. Only one subject marks I'm talking, and I will then print them. Okay, so you will define, always it's good to define your structure as global, and always your structure name, because struct is a keyword followed by name of the structure. In your name of the structure, always the first letter it should be capital. It is very good to write like that. Student. Under this we have name, character, name of some size, let's give as 10, then int roll number, then you can have int marks. Okay, then you can use some structure variable. Let's let that variable name is s. Okay, this is your definition of your structure. Then you have your main method. Here how you will read scanf. Control string is percentile s for name. I told you will use dot operator in order to read the inputs for your members of structure. So I'll write s dot name. Okay, then in order to read roll number, I'll write scanf percentile d address of s dot roll number. Then scanf, in order to read marks, I'll use percentile d address of s dot marks. Okay, this is the way how I'm going to read the inputs for your structure. Okay, so now how to print. So I'll just show you this program, that will be better, so that I can show you all the modifications. Just give a couple of minutes time. I'm just writing printf to make it fast. Only one printf statement. You can write it as you like. Scan it. Percentile s, comma s dot name, percentile d, comma address of s dot marks, scan it. Percentile d, address of s dot roll number. Okay, so this is the way how I'm going to read the inputs. Okay, I'm just showing you the small example. You can take many things also on this. But this is the basic thing which they expect in your GEP patterns. So how do you read the same variable name? You can use it for printf. Okay. So this is one method of defining your variable, and some do it here. Very similar line. It is very similar there. Struct student followed by parameter name. This line number 10 is very similar to declare the variable is in line number 7. Okay. Uh, Anyhow, I'll be using throughout the program. That is the reason I will define like that. I can continue it. This is capital here. Oh, and then make it small here. So I'll write from ABC 12 and let's give 50. Okay. Okay. Yeah. So I'll get name is ABC, marks is 12, and roll number is 1. So this is nothing but reading a simple structure. Now this can be modified like this. I'll write here, see now here, array in a structure is different from array of structure. Okay, be very careful when the question is asked. If they ask you to you write a simple program using array in a structure means this is very simple example, but you can modify if you are talking. For a single student, I want to read 3 subject marks. I'll make it as this. So this is nothing but you call it as array in a structure. There is lot of difference between array of structures, and there is difference between array of structures and array in a structure. So this is nothing but you are calling it as array in a structure. Now, how does that changes? We'll see. Let me take this and just modify and explain in 1 minute. Okay. So now you observe here how this happens. So this is nothing but I'm talking about array in a structure. You are defining an array in a structure and how you are going to access that. You see. Now I have a student class. Okay. Where in student class we have 3 columns. Okay. What are those 3 columns we have? First one. The first column name, you're calling it as name. Okay, you're calling the first one as name. The second column is marks. And the third column is roll number. So this is one individual column, and these row values may change, but the column is common for student. Whoever run the program, new row elements can be entered. Now when you see this marks is again divided into three columns. Okay, how many marks you are taking? Three subject marks. So I'll take the index from 0. So 0, 1, 2. Okay, we have defined one field value, that is array, in a structure. That is nothing but you're talking about marks. Now when you come to the main, so this is referred by a common and only one variable. That variable name you have referred it as yes. Okay, you are using your reference variable as s there. Now you will ask the student to enter marks. First you are going to need name. So let's give the name as XYZ. Now you have to read three subject marks for a single student class. Okay, so I need to repeat the loop. So I'm using here for loop. When I value is 0, okay, when I value is 0, I'm reading the first subject marks to the student. Where it is stored? Address of s of 0 dot marks. S of 0 dot marks. So 40. When I becomes 1, S of 1 dot marks 50. When I becomes 2, I'll get S of 2 dot marks, that is 60. Now I have completed reading for a single student, 3 subject marks are done. Now I need to read roll number. I'll read roll number something 45. Now how do I print? First XYZ name is printed, S dot name. Then I should print S of 0 dot marks. That is the reason again I'm using loop here. So I get S of I dot marks, 40 is printed, then 50, then 60 is printed. Okay, this is the way how you will read an array in a structure. That's all. So if they ask you to explain an array in a structure, you take the best example of student structure and you will write and explain him show this diagrammatical representation and write your expected input and expected output. That fetches you the marks. Anyone has any doubt with this example? If you have, let me know. Otherwise, I'll go with the next concept of structures. Ma'am, is it s dot marks of air? S of I dot marks. What I didn't get? What did I write? Something mistake there? Ah, sorry. S dot marks of I. Correct. Sorry. S dot marks of 0. Correct. I'm sorry. It's correct. This is array instruction. No? Correct. S dot marks of I. Correct. I'm sorry. Okay. So this is about your array in a structure. Now we have the next one. Let's talk about array of structures. Okay. So when we use this array of structures concept is whenever you have a collection of homogeneous elements, okay, understand, whenever you have collection of homogeneous structure but you have collection of heterogeneous elements. Understand, here we know what is an array. Array is collection of homogeneous elements. What is a structure? Structure is a collection of heterogeneous elements. But when we use this combination is, for example, if a university is if let's take your university or let's take your college database. If you observe your college database, okay, they will define one common structure for a student. Like they will let's take they are maintaining some student database like name, roll number, and branch. Okay, let's assume only three fields: name, roll number, and branch. Now, when you are reading name, roll number, and branch, now this name, roll number, and branch are collection of heterogeneous, but this structure is common for any student who is going to join this college. Okay, understand here. Now I'll just show you sample thing. So now I have a student structure. Okay, in this student structure I have three fields now, like name. Okay, then I have branch, then I'm maintaining something called as, let's take his roll number for example. Now the column attributes are common for any student who is going to join this college. I'm maintaining a student database. In my student database always I'll make the entry of the name of the student, branch of the student, and what is his roll number for time being. Okay, let's assume. Now, the column values are same for any student class to enter into this database. But what are the values that is going to change? Only your field values. Okay, now if you observe, even your student is collection of heterogeneous elements. This is common for n number of students. Whenever you are saying common elements or similar type of data, then it comes as a category of array. So what will I do? We all know that. So one variable can hold these fields. Like if I define S can hold the field value of name, branch and roll number. That is, it is referred. Now I have to make this S such that it can read n number of students. So definitely, as the structure is common, as the structure is becoming homogeneous collection, you will make this as an array. So this is array of structures. Okay, you are making an array collection of different structures. Okay, collection of different student data. But the collection of student data, the values may be changed, but the data type is of type structure. Okay, so what should I do is, let's take the same example. Okay, we'll do with the same example. So we'll take the same example now. What I'm saying, I want this student class for n student. So let's define some 10 here. Okay, I'm taking a maximum definition. Okay, so instead of here 3 marks, I'll just take one subject marks. That is more than enough. Okay. Um, Now the difference is, I'll just show you that. Okay. Now what I have to do now? This is smallest, right? Okay. Now I'm reading this structure for n students. So I'll write here. You can read one more variable comma n. I can write here print for I is equals to 0, I less than n, I plus plus. I'm reading this structure now. So here we need n value. So I'll write that control string percentile d, comma address of n, in the semicolon. Then you can ask enter details for percentile d student. So comma I plus 1, because I starts from 0, get it as 1 per student. Then we'll do it here. So now you have only one subject mark, so there is no need of this. Okay. If you want to, okay, let's take 3 subject marks. There is no problem. Let me take that one. If you are reading 3 subject marks here, okay, I'll just explain you that on the better option. Because if you are asked for finding total average and S of I. Now what happens? Your S is not S dot name, it is becoming array. So I'll write S of I dot name. S of 0 dot name. So the first student. Then here S of I. So I'll make this as J, so that you will not. So J plus plus. So I can use here J now. S of I dot marks of J. Then here S of I dot roll number. Okay. This is your first here C. Then we can print here. S of I dot me. Then S of I dot, okay, S of I dot marks of J. Then S of I dot roll number. Okay. So let me explain, then we'll exhibit. Okay. So here it's fine. Now I have a student database. Okay. In that student database, what are the parameters I have taken? The first one is name, second one is marks, and third parameter is roll number. So name. Okay. Next one is marks. Then we have roll number. Okay, now these are the parameters. Now again your marks are categorized as three fields: 0, 1 to 3 subject marks. Now these are referred by a single array variable s. Let's take I gave n value as 2. Okay, so we have here two variables. One is ith variable which is referred for your row, and we have the another variable j also. Okay, now first you will ask name n is taken as 2. Enter details of percentiles t. So 0 plus 1 it becomes enter the details of first student. So first it will read s of I dot name. So it is reading I initial value is starting from 0 here. So it will read s of 0 dot name. So first name, let me give it as x, y, z. Then the next one is marks. So j is equal to 0. So where we have to read for s of 0 dot j of 0 I have to read. So that is nothing but s of I dot marks of j. So I'll be reading the first subject marks. Let's give 4. Then s of I dot j. Then this is done. When this loop fails, then you will come for reading the roll number. So I'll read the roll number as 112. This is completed. Your outer for loop I is incremented. Now I again starts from 1. So you're reading the details for S of, this is S of 0 column. This is becoming S of 1th column. Okay. Now here I'll have ABC. Let's give it as 8, 9 and 10 marks. Then let's read the roll number as 13. Now this is completed. Loop fails. Now when loop fails, you start printing. You start printing from 0th location. So your details printing as S of 0 dot name. What is S of 0 dot name? XYZ. What are marks there? S of I dot marks of j. So first one 4 is printed, 5, then 6. Then your roll number is printed, S of I dot roll number. Then the next field I plus plus I becomes 1. Then you get ABC 8, 9, 10 and your roll number is printed. So this is the way how your structure for array of structure is stored. Now we'll see this. So I'll just put some comma so that you will be confused. So let's give 2. Enter details of first student. It is asking for name, marks and roll number. Let's give name as Alice. Let's give marks 40, 50, 60. Then the next field is roll number. Let's give roll number as 56. Okay, we'll give it as 1, 2, 3, 4 roll number. Okay. Then enter the details for second student. Now you'll get it as Bob. Let's give marks 89, 69, 63 and let's give roll number as 4569. So you can see the details are printed. Okay, you're getting only first one. Okay. It's not repeating. Okay, this is Jano. I took 5 years. I'm so sorry. So we can give here 2 alive. 56, 58, 59, 1, 2, 3, 4, Bob, then it's 45, 85, 79, 89, 60. So if you see the first two details of first student, you got alive 56, 58, 59 his roll number, and details for the second student if you observe, and details for the second student if you observe, you are getting Bob 45, 85, 79 and 8963. So this is the way how you will pass and how do you read an array of a structure. Passing array in a structure is, I have explained you how to read an array in a structure. This is array of structures. Anyone has any doubt with this, let me know. I'll give you 1 minute time and go with functions to add structures. Kindly let me know anyone has any doubt. Hope no one has any doubt. So we'll do the same thing. How to pass a function to a structure. Function with, okay. So I'll just take small parameter. So we can use here structure variable. Let me complete, then I'll explain you. I'll define an student structure. Then I'll write structure student, student. I'll take a function like this way. So it is written as something. So inside main method, I'll just because here no need empty name, it is not returning anything. So let me remove all these. Okay. So this is also not necessary. So here you are this is a function with return type but with no value. So I'll write s is equals to display. I just call that method name. How do you call? Okay. So you will call x is equals to display name. Here you can print the details here. Okay. Like print his name. Name is equals to percentile s, comma s dot name. Then print roll number is equals to percentile d as dot roll number. This is your main block. Then you have your display block. So struct, okay. For student class, you are writing the definition for display. Percentile s comma s dot name scanner percentile s sorry percentile d comma address dot s dot roll number and for the field you have to read. Okay, that's all. So this is the way how we are going to read, I mean how we are going to pass a function to a structure. Okay, so if you observe here, I have a category number 3, like a function with return type but with no arguments. So Here I'm taking a global declaration display here. Okay. So display, we are defining a display method. Now inside main, I am calling the function display, which is referred by a local variable s, right? Sorry, global variable s. Now s is equal to display of. So what happens when this function call is made? First you are reading name and roll number for the student. Okay. Now what, you are reading the name and roll number of a student. Now here if you observe, what is the thing? We have to return what? That is the reason I have written. So which variable you will return? Obviously, your entire structure like your name and your roll number of a student class is holded by a single variable that is nothing but yes. So here what will you write is, we will write a simple statement called as return s. This is only one input, one output variable which you are passing for this. So that value will be stored here and you get the name and roll number of the student. Okay. We'll see this now. So let me execute. Let me check whether it works because it's global here. Let me check that. Yeah, it is conflicting types. This is student small and this is practical, right? So we can give name. Let's give Bob. What is the other one? Roll number, I guess. Bob. 12 roll number. So why I got garbage values? Seriously? Okay, I didn't write return. Sorry. Return S. So Bob and 12. So I got here name is equal to Bob and roll number is equals to 12. Okay, this is how to return. Suppose if you want to, what do you say? Suppose if you want to pass the arguments to the function, how will I do now? What will I do the change? So this line, mm, this doesn't make sense here if I use also. I'll do one thing. Control X, Control V, then I'll do one thing. Control X, then I'll write here Control V. I just want to return here. This is a function with arguments I'm talking. Okay. So how you write a function with arguments now? So void display. Where is your void? So this is void now. Void display, student display. So here what I have to pass now. So what will I do? I'll take another void display because it's not returning anything now. So return type is empty. So I'll write stuff. Just try to what should I do here? We pass this here. Mm, or else I'll do one thing, not right here. You can do this here. Student, that variable name I'm passing here. Okay, that is with argument. So inside main I'll read this. There is no need of calling function here. This line number 11 is ignorable here. After I read, what will I do? For display, I will pass the parameter name. Okay, for display, I'm passing the argument that is nothing but s. You have your input in s variable, right? So I'll pass there. So student display, void student display, and here it is taking same thing, struct student of s. What happened? Okay, I'm using here capital S. So sorry. What happened? Name is not taking the local variable. Okay, we'll do one thing then. I'll not define here. I'll make it as global here. Expected something. What is it? Something. Expected semicolon. Expected student. Yes. Is void name is not here. Okay, it's happening. Void student class and passing. Display of s. Then nothing. Struct student expected in line number 17. Void student display. display function. Okay. So now you observe here. Uh, uh, so this is the way. mm, so this is a function with arguments but no return type. So I have taken a display function which is taking one input argument, that is nothing but you are passing a student for the function structure, and all the structures are holded by a simple variable s. So finally, whenever you are talking about main, I said when you are passing the input, whenever you are saying a function with arguments from main, you have to pass your inputs to the, you have to pass the inputs to your called function, right? So your inputs are pointed by simple variable, that is s. So I'm calling display of that s. So with the help of this s parameter, I'm printing the name of the student as well as roll number of the student. Suppose if you are returning, simply you'll write return s. That is whatever the variable you are going to define in your structure. That's all. How you pass your structure. It's very simple, very similar to your function. I mean, so here you will be passing a struct student. Generally, you pass int some variable name, right? Here you are passing your student structure to the method. Okay. So if I execute, so I get Alex and roll number is 12. So this is the way how you pass a function to a structure. Now we have the foremost thing, that is nothing but how do you pass a reference to a structure. That is nothing but how do you use your pointers in structure. I'll tell you that. Anyone has any doubt with arrays, how to use arrays and how to use your functions in your structures? Let me know. Just take a couple of minutes. I'll give you 1 minute time. Please let me know arrays and structures with functions and structures of arrays. Because one show the which one you want, functions. Okay. I'll just show you. This is a function with no return type. That's the reason you are making the method name as void. Yes, this is a function with no return type but with arguments. Exactly. With arguments only, because we are passing here student, right? We don't pass individual like name, roll number, like how do we pass a normal call by values in your function. We don't do that. Here we pass your entire structure for your display method. Okay, complete structure. Yes, yes. Suppose if your structure name is employee class, struct employee class, void display struct employee. Okay, you will make. So I made s as global variable, so I don't want to use many local variables. So one simple variable can be act. So this s is acting as global for all the functions. You can also have local variables and you can also read the values. That is not the issue at all. Okay, okay, fine. Then let's talk about point. It's very easy now. See, now I'll show this example only. I just will see. Okay, now see the difference, very small difference. So here normal program, normal structure definition class and your pointers. Only the small difference is the thing which you have to remember. Mm, okay. Um, so how do you pass? So very simple thing this is actually. So this is not this. We are talking about pointers with structures. Okay, pointer to structure class. So I told you, in order to access your members of structure and your variable which is different, how you form a link is, that is how you pass an interface is, we are using an operator called as dot operator. Now whenever you want to refer, that is whenever you want to have a reference to your structure members, we will definitely use a pointer. Now dot operator is helping you to access the members of structure. Whenever you are passing your, whenever you want to use a reference, definitely you have to create a pointer. Now how a pointer access to the member of structure is by using an operator, that is indirection operator. You call this as indirection operator. That is only the change between your normal structure accessing and pointer. So you will be instead of dot, you will be using here arrow operator, which acts as an interface to the reference variable and members of your structure. So how you will create that, I will just show you now. So so I told what. So let's take one S variable, and now I want to create a reference to a student structure. Okay, I want to create a reference to a student structure. Like, see, I want to create a reference to my student structure. So I will create a pointer. Okay, I have a student structure where a student has two field values. One is name and the other one is roll number. Okay, now I want to create a pointer which refers to my student class. Okay, now for example, if you have an integer variable a, if your pointer wants to point to a, you will create this pointer of type int. Suppose if you have a float b, if you want your pointer to refer to a floating point value, you'll define it as float. Similarly, a pointer have to refer to the variable that is of type structure. So definitely I should create my pointer of type structure. How do I write struct? For whom you are referring? Your structure class. What is your structure class name? Student followed by variable name. This is your declaration of pointer of type structure. That's right now. I'll show you now. So here, what do I do? The P1, which is very similar to struct student start P1. Okay, which is very similar to this. Generally, if I write, like for example, if I write int a is equals to 5 comma star p1, how I'm writing the reference for p1? I'll write p1 is equals to address of a. Right, this is the line which you do if p1 want to refer to your variable a. Now similarly, p1 is a pointer variable which is referring to a student structure. I'll write what is a variable. P1 is equals to address of s. That's all. Now why this is not happening? Okay, now here instead of s, even you give here a problem, you can you see use pointer variable to print the values. This is not there. Interesting number, name and something else. Oh my god, seriously. Also, name roll number is not different. Even is equals to address of else. Okay. We can create here pointer type. Okay, let me check here once. But this is not working. Interesting. Right? Interesting again. Okay, dot. That's right. narrow operator. Sorry that you can expect like this. So here we can write here. That's what it's star evil. So here this is very similar. Okay. So we have to use arrow operator. Correct. So I'll write ls and let's do 34. So I'll get name as roll, ls and roll number as 34. Now I can do here. So many things can happen. So why do we need reference is whenever I want to change the actual arguments. Like for example, I have my database I told. So if I change something, if I can't always go for my database and search some details. Somewhere I'll write something such that it will affect the original data. So whenever you want to do the modifications on your original information, then you can have your pointers with structures also. Okay, so I can write here after I rename here roll number, right? I'll do one thing here. I'll write P1 dot roll number is equals to 56. Now, for example, we see what happens here. P1 dot, sorry, I'm confused. Pointer, no? Now you see, I give allies. I am passing my roll number as 45. But now you see, I get allies and 56. Can you see everyone? You got allies and 56. So that is a speciality of pointers. You can modify the original contents of your information. Now instead of here S, I can also read with P1. Okay, I can use P1 arrow roll number, and to read the name, I can write here P1 dot name. Okay, I can write P1 arrow name, and here I can write S1 dot name. So both P1 and S1 indirectly are pointing, both P1 and S are indirectly pointing to the same location. Okay, S dot roll number. So now I give Bob 70. I'll give this. Okay. So this is the way of passing here or a pointer referring to a structure. Anyone has any doubt with this concept, pointers and structures? Anyone want any another example? So you have self-referential structure. You can write your best example of creating your single linked list. Okay, self-referential structure is nothing but you are creating a pointer inside your structure. Okay, you are creating a pointer who is pointing to your own reference way, own reference structure. So you can write the best example as well. Anyone has any doubt with this? Yeah, I forgot there. That's only. Okay, so this is becoming your local and this becomes your global declaration. Anyone has any doubt with this? Otherwise, we can go for type def. So understand here. So what do you mean by type def actually is you can define a new name for the existing data types. Whenever you want to create a new name for your existing data type, you can use your type def function. Okay. So just a type def is nothing but giving a name. Okay, giving a naming convention for your data types. Okay. So what happens is like for example, let's take this example itself. Mm, So we all know that struct is the keyword which is defined for your student class now. Okay. So what can I do is I can type def my structure. Okay, I can type def my structure so that I can give my own names like this. Let me take an example, simple example, so that you So okay. Now you don't want to use your structure, that is you or else we can do one thing here also. So you don't want to use your structure class here, that is you don't want struct as your keyword. It can be used in different ways, like okay, like for example what will I do is, for structure I will type define. I'll write here, how is the syntax, I'll write here first. Syntax is type def, okay, type def for which parameter, that is for the existing, for which, like for example for struct, okay, that is you will take the existing data type and you will have new name for that. Okay, this is the syntax you have to use. Now what I'm doing is, I will type def my keyword struct. You can have your own names also, like I'll write here type def, okay, type def struct, okay, type def struct followed by your new name. Okay, so let me take my new name for my structure class. Here I have to write that name. Let's define as something like alias, okay, and this is s variable. Now I'll not create here s. What will I do is, generally I told you can create here struct student some s here, right? This is also correct, I told you. Now instead of doing that, what will I do is, instead of using struct I can use my new name as what, alias. Okay, I can use my new name as alias. I can create one simple variable s. Okay, so I'm defining my struct student with a new name as alias. So wherever I want to use struct student, I will simply use the naming convention as what now, alias. So wherever I want to use my struct student, I'm using my naming convention as alias, and I'll write that variable. So I get that. Understand here. I'm so wherever I want to use struct followed by student class. Okay, wherever I want to use, I am defining type def data type. For which data type completely, this for struct student, I'm replacing it with a new name. That new name is nothing but I'm talking it as alias. Now, generally, how do you define your s variable? I'll write struct student s. Instead of that, now I'll write alias s. Whenever I want to create a new variable for this structure, I can directly write alias followed by the new variable name. So type def is nothing but whenever you want, any user want to give his own name for the data types, okay, predefined data types or user defined data types, he can use that. Anyone has any doubt with this type def? Anyone has any doubt with type def method? So we have another thing that is nothing but, let me talk about bit fields. So we let's talk about bit fields now. So first of all, understand what is a bit field. So bit field is also a data structure which is used for your computer programming. Okay, so actually it is talking about it is nothing but it is a combination of sequence of bits actually. Okay, bit fields is nothing but which is capable of holding a sequence of bits finally. So how these bit fields are used in C languages? Suppose if you are confident, whenever you know that this for particular variable, it always occupies only certain amount of memory. Okay, if you know that this particular variable will always occupy only certain amount of memory and certain number of bits, then we can go for bit fields. Like for example, I have a variable a. Out of 16 bits, it always uses only 2 or 3 parameters. Then what do I do there? I will only create the bit field value there. Okay, I will be creating the bit field length, so that wherever I use that parameter, okay, wherever I use the parameter, what will I do is I will have my own memory size. I'll just show you the example, then you'll more clearly understand actually. 1 minute. So let me give an example. Suppose for example you have a age. I have defined it as int. How many bytes of memory? If it is a 4 bytes compiler, it will occupy with 32 bits. And you all know that age cannot exceed more than 3 bits. That is nothing but you can't, it won't take more than 3 fields, that or else you will have a maximum of a 2-digit number as your age. Okay, like it is for something between 0 to 100, right? 0 to 100. So in order to represent your 0 to 100 numbers, how many bits will be using out of 32 is your question, first one. Or else for example, let's say you want to represent a date, like it is 31 days. Maximum you are using how many bits? 31. That is, in order to store 31 out of, like for example, I have here, let me make it more clear. I have 4 bytes, okay, which is 0, 1, 2, 3, 4, 5, 6, 7, 8, and so on up to 15. That is 2 power 0. So this is 2 power 0, which is nothing but 1, 2, 4, 8, 16, 32, 64, 120, and so on you will be having. Now if I say int date, so we all know that your range of date is only from 0 to 31. That is first to 31 days. Maximum in every month you have only 31, 30 or 31 days, right? Excluding your February. Now, in order to represent 31, if my date is given as 31, how many bits I'll be using out of these 16 memory locations? How many bits I'll be using? Only this much, right? In order to represent 31, I'll write what? 1, 1, 1, 1, 1, and this is 0. Am I right? So the remaining amount of space is wasted. So how your bit fields will help is bit fields helps you to optimize memory wastage. Whenever you are confident in only this much amount of memory or only requires this much amount of space in your memory, then it is very good to use your bit fields. Okay, since we can optimize the space using your bit fields. This is the simple thing. Optimize space using bit fields. How do you see this? So you are mainly right, unsigned, okay, int some date with number of field values as 5. Okay, so now this understands that you are using a bit. D will have value the date, like dt is a date which will field values as 1 to 31. So maximum number of bits I will be using is only 5. So now your compiler will allocate you only this much amount of memory. The remaining space is not allotted for your variable. Okay, so bit fields for optimal memory space. So we have one more thing here, enum and unions and files will end it by tomorrow. Union will take time, and files is the thing where we have few three which you let me know. Only bit fields are used to optimize your memory space. Okay, so hope everyone are clear with this today's concepts. Let me end the session. If anyone has any note, let me know. I'll give you 1 minute time. Okay, fine. Thank you all. So we'll just stop the session. Tomorrow I'll just share the class timings.